In this chapter, we'll talk about the attributes that are supported in Hoops Visualize, including how to control setting attributes, how they inherit, a specific subset of attributes referred to as materials, also attribute lock, and then we'll get into an exercise about how to use them. So we've reviewed segments and geometry, and the third part of the triad, so to speak, is the attributes supported by Hoops Visualize. They describe how things should look as opposed to what's in the scene graph. Now, it's more than just visual appearance. These attributes can sometimes control rendering, algorithms that might affect performance. In many cases, they're some of the most important attributes that are supported. But here's some examples of the types of attributes that we support to control visual result. Patterns, weights, colors, symbols, selectabilities, a tremendous amount of text attributes that we reviewed previously. So pretty much by default, all attributes are supported at the segment level. Some can be set on the level of specific piece of geometry or subgeometry, but there are just a few exceptions for that. And each segment has one opinion about each attribute. That's very, very important. Again, an exception being shells and meshes, but putting that aside for a moment. So if I have a segment and it says, lines are red and faces are visible, and so on, all geometry in that segment will be affected by those attributes. So the goal of the scene graph guideline is to group entities that you want to be rendered with similar attributes into the same segment, or as few segments as possible. That is very, very important for performance. It is important to minimize the number of segments in general whenever possible and group things by like attribute. Okay. Attributes are inherited from their parent segments, and the root segment of the whole scene graph has a default for every single attribute. If we look through the documentation, you'll be able to find a document that reviews defaults, the actual defaults for all different attributes. I think we can find those in the appendix, and here we are, Appendix B, default attributes and options. So as we scroll down, we see the defaults for every single attribute. It's important to keep aware of these because sometimes you might notice that, hey, something's coming out a really strange color, like all these things are black, or something's not showing up at all. That's because many things will have a default visibility that you might not expect, and it's usually fairly consistent where everything will have the same initial color, such as black. We did not try to have the defaults have specific different interesting choices of color. Things are just going to be black, and it's up to you to decide what the appropriate default colors are for your application's needs. And as mentioned, objects with the same attributes should be grouped into the same segment or as few segments as possible, and reduces memory usage, improves performance. And the priority that we apply attributes in is first the local attribute, then if an attribute is styled from another segment using a named style as we reviewed earlier, style segment. And then if there's no local attribute set explicitly on a segment and there's no styling of another attribute, then that segment will inherit its parents' attributes. So that's kind of the order of precedence for attributes. So we've touched on this a little bit in a few exercises, but the way that attributes are generally set and queried are via controls. So think about attribute controls. So the way the nomenclature here is the attribute category, and then there's a control for that. So here's a camera, there's a camera control, let's say. So I have my segment, I have a key to my segment, I'm going to get the camera control, and in this case I'm going to query or ask or show the projection. The show will give back to me the current value for that attribute. And for edge attribute control, we have another example. We're going to get the edge attribute control for a segment. Every segment has the same attributes, the same controls. And we're going to set the edge weight to be 3. And if we want to know net attributes, so not the attributes that are explicitly set on a segment. Controls only show values of attributes that are definitely were set on that segment. Remember, if nothing was set, the attribute might be inheriting from above. You have to use a key path, as we discussed before, to get the net or possibly inherited value of an attribute. Again, the key path will specifies a list of keys up to the root. Remember, there's could be reference things. Segments could have been included. Geometry could have been referenced. So that key path will resolve that ambiguity. Okay.
So one of the most important attributes in Hoops Visualize is materials. They're used to influence how geometry appears, how it's colored. We can see different aspects of the color channel here. Transmission or transparency would be defined by the material's properties. Various types of texture mapping or environment mapping, including bump mapping. So they're a very key part of the attribute support in Hoops Visualize. They can be applied in a variety of ways, and one approach is to use kits, as we've covered in the past. Kits are these transactional objects that exist outside of the database. So here we have an example where we're setting up a material kit, and we set up a couple different color channels. So diffuse texture, specular gloss, and whatnot. And then kits could then be applied using a material mapping kit, one of the set methods, and there's a wide variety of capabilities once we look at this API documentation. So if we wanted to, let's say, set the edge material and pass in a material kit, or we could have set face material. We can also directly apply, instead of using material kits to set edge, face, or vertex materials, or colors, if you will. I like to use the word colors sometimes. We can directly use the material mapping kit itself to control specific, pass in actual colors for edges or faces or vertices, or for pass in specific textures for faces and edges as well. So that is one of the ways we can apply materials. And moving on, we'll look at an additional set of approaches for applying materials.
So here we'll actually just kind of directly apply to a segment. We're not using something called a material palette in this case. We're just kind of going direct. So I have a segment key. I'm going to get the material mapping control, and I set face color. So anything that is subject to faces in that segment will be drawn with that specified color. Remember, any polygons or circles or ellipses have filled faces. Any shells, meshes, cylinders, polycylinders, spheres have facets, so they have both internal faces for their facets, and they have edges for their facets, borders. Okay. Another example, I'm going to set a gloss. Okay, get a segment key, get the material mapping control, set face gloss. So that's convenient for making small adjustments, but if there's a large amount of things that need to be set, we would use material palettes. Okay, so that's going to be a collection of materials, and palettes reside in what we call portfolios. We can have all these different active portfolios that can be set up and activated on a segment. So these palettes, as we cover here, you can apply, you could apply transparent materials to sub-entities as well. With a direct attribute control, material control setting, that's not possible. So palettes basically using material palettes, defining a material palette gives you a lot more flexibility. So the steps here, there's 4 steps. You define an array of materials. Here in this case, we define an array of materials. Okay, we have some diffuse. We've set up a gloss. We have 3 different materials in here. Index 0, we've only set diffuse. Index 1, array index 1, we've set up diffuse and gloss. And then in our array index 2, we've just set up diffuse. So we define an array of materials. Then we define the palette through a portfolio. Okay, we get our, we've set up a portfolio. We have a portfolio and we've set up a material palette. And we pass in that material kit that we just set up here. Okay, our material kit array. So we have this material kit array active on that portfolio. We have to make that portfolio be active. Okay. So my segment key, set the material palette, make this active. Okay. I'm sorry, this makes the palette active. And then finally, we would set up the index we want. So we have our segment key, we get our material mapping control, and we can apply that, within our segment. Okay. Sorry, this is the direct way. Down here is how we would actually use the palette. So we set up our portfolio. We've defined our material palette based on the kit up above. We've set that to be active. And then we actually are going to, on a segment, set a face material by an index into that material palette. So this is a direct, clean, and simple way. And this is the multi-step way using material palettes down here. Okay. So another bit of advanced usage here is we can also apply materials at the geometry level. We said previously that you can have attributes are all supported at the segment level, and materials can also be at the segment level. But actual shell and mesh and polycylinder geometry, you can specify materials just on a specific piece of geometry. Okay. And only some materials are supported, like color and visibility. There's all these different materials supported at the segment level are not supported on just shells and meshes. And not only that, but only certain parts of geometry are supported. So in this case of shells and meshes, certain materials are supported on faces, edges, and vertices. Okay. So if we want to do it the entire geometry level, so I have a shell, in this case I have a shell kit. I could have had a shell key, but I'm going to say, okay, set material mapping, my material mapping kit. So I've already set up some face color in this kit. And so that on this specific shell, I've set up this kit. So just this shell has a particular face color. So shells and meshes break this rule of everything in a segment has to have the same attribute. So this segment that this shell is going to reside in could have had, face color could have been red, 100. And in this case, I'm applying a blue color just to this specific shell. I could, in this segment, I could have a whole different set of materials defined in my array of materials, and every single shell in that segment could have a different face color. It actually doesn't generally cause performance issues, because the idea being that, shells, if you have multiple shells in a segment, usually more often than not, the shells might be much larger and might have hundreds, thousands, tens of thousands of facets in them, ideally. And so typically not too big of a performance issue to have one segment with many, many shells in it, and each shell at the top shell level might have a different attribute. Okay. And then we can also do subgeometry. Okay, so this refers to individual faces, edges, and vertices. So here we actually have a single shell, and different faces in the shell have different colors. This is only recommended if you are using hoop shells to represent something where you definitely know you need a single shell to represent all of these connected facets, but different faces or edges or vertices need to have a different color. That might be common in certain types of industries. For example, in the mining industry, various companies will have a single shell that represents like a chunk of earth, like ore density, some type of geospatial region, and they'll have a kind of a block structure. And rather than having one shell for every single cube that are all adjacent, they'll have a single shell, and then they'll color different facets to show some type of physical property. It might show some type of density of ore, like concentration of ore, based on that sample set that they had inside of that area, that volume of earth. Another example would be finite element analysis, where someone will take a mechanical CAD part, it has some type of a facet set, and then they'll do and they'll mesh the part for purposes of doing some type of analysis of material physical properties. And then each face might have a different color in the end. It might have, each vertex or each edge might have a different color. And that might be a color into a color map. And those colors are used to represent some type of external material, physical property information. So generally, if people are interested in applying materials at a subgeometry level, you should have a specific use case and check with our developer support team or consulting team to make sure it's a good, sound usage of that. A couple other important attributes would be modeling matrices. So it's an attribute of a segment, just like any other attribute. Each segment has a 4x4 matrix. When there's a modeling matrix, that's used to transform any geometry in that matrix from its local object space into the world space visible by the current Hoops Visualize camera. And we'll cover cameras a little bit more, so we'll get into modeling matrices a little bit more when we talk about coordinate systems and cameras. But it's basically just an attribute of a segment. And you guys are familiar with the concepts. We can translate, rotate, or scale entities. So we do have convenience routines for that. And you can also apply matrices directly by doing a concatenate, or actually just set a modeling matrix and pass one in. Okay. They behave like other attributes, where they affect all geometries of the segment, but they append to each other up and down the tree. Okay. So let me see if I can quickly open up a let's see if we go through here. Go into coordinate systems really quick. So any local modeling matrices set on a segment will transform those objects in that segment into the world space, which is visible by the camera. Okay. So this is our object space, transformed now. Again, we'll get into that a little bit more detail when we talk about these coordinate systems in a future chapter. I think this is one of the last sections here. So attribute lock is something that kind of lets us break the attribute inheritance rule. Let's see, we can get down here and talk about attribute locks. So this allows attributes to be temporarily overwritten. And so let's say you have an attribute at a top level segment, and subsegments have their own opinion about attributes further down the tree. Well, if I'm going to lock an attribute at a certain segment, it's going to force that attribute to override everything down the tree as long as that lock is active, and then you could unset the lock. Okay. So for example, we say you may have a model with a subassembly which has its own attributes, but then you might want to temporarily have the parent model attributes take precedence and kind of force its opinion down through its children. Okay, kind of like in real life sometimes. Yeah. So this is a code snippet example of attribute locks. We get an attribute lock control because it's an attribute, and how do we control attributes with controls? And we set up this lock, and there's many different sub controls over attribute lock. Like, what are we going to lock? Okay, well, here's everything that we can lock. We could lock different types of visibilities, materials, material channels. So there's a lot of control. Most lock is over has to do with subparts of visibility and materials. Not every single thing can be locked down the tree. Okay. So the next step would be to go through some exercises on attribute setting. The recommendation would be to go through section 1.3 of the fundamentals tutorial, which covers setting attributes. And then we'll have a couple little enhancements to that, setting up some transparency. And these two samples in particular cover how to set up a few example segment level attributes and also shell attributes. So we referred to those earlier, where we set up material palette and material indexes, material arrays, and we can set attributes at the shell level or subshell level.